Okay, so in this video, we're going to be talking about our three basic trig ratios, and that is going to be sine, cosine, and tangent, okay? And how to apply them when we're talking about a right triangle. Now, it's important to remember here that these trig ratios are pertaining to a right triangle, meaning they can only be used with a right triangle, so don't try to apply it to a triangle that is not a right triangle because it won't work. We have things like the law of sines and the law of cosines when we're dealing with non-right triangles, to go ahead and solve for missing parts. So again, when we're using these trig ratios such as sine, cosine, and tangent, we're using them in right triangles, okay? And there's a little saying that you can remember here to help you remember what each one means, and that is SOHCAHTOA. So if I look at the first part here, SOH, that's talking about sine. And you can see that the letter S represents sine, and then OH represents opposite over hypotenuse. And again, we're talking about a right triangle here, and we'll have more examples of this, okay? With cosine, you have CAH, and so C represents cosine, AH represents adjacent over hypotenuse. And then if you look at tangent, which is going to be TOA, the T represents tangent and OA represents opposite over adjacent. So again, the saying you can remember here is SOHCAHTOA, all right? And so why don't we go ahead and look at the next page so we can get a clear representation of a right triangle in all the various parts. So here's our right triangle and all the various parts of our right triangle. You can see that we have 90 degrees right here, and the angle in question is right here, theta, okay? So based on the placement of theta right now, this is how my triangle is going to be labeled, where opposite of theta is right here, okay? Adjacent is right here, and then you have your hypotenuse right here, okay? Now the placement of theta, or the angle in question, could change. So for example, let's pretend this isn't here, and let's say that theta is here. Well, your hypotenuse is going to stay the same, all right? But opposite and adjacent are now going to flip. So this side here is now going to become adjacent, and this side here is now going to become opposite, okay? So just keep that in mind. So with all of that being said, why don't we go ahead and try our first example? So here's our first example, and it says find the three trig ratios. And again, we have a right triangle, meaning we can utilize sine, cosine, and tangent. Now, I can see that the angle in question is right here, theta. And we do have a missing part here. So before we go ahead and list out these trig ratios, we want to find this missing part, x, okay? And that's fairly easy. We're just going to use the Pythagorean theorem to go ahead and get that. So writing out the Pythagorean theorem, that's going to be x squared plus 6 squared equal to 7 squared, which ends up giving me x squared plus 36 equal to 49. From here, I have to subtract 36. So I'm going to do 49 minus 36. And when I do that, I get 13. So now I have x squared equal to 13, okay? And now I have to take the square root on both sides. Now, it's not going to be a perfect square, but you're going to end up with x is equal to plus or minus the square root of 13. Now, think about this logically here. Technically, we have two answers. We have positive square root of 13 and negative square root of 13. But we're talking about a length here, okay? So a length can't be negative, meaning we're only going to be looking at the positive here. So x is going to be the square root of 13. Okay, so I'm just going to go ahead and write that in. And from here, we can go ahead and get our trig ratios now. So for sine, I'm going to say sine theta. Well, what's opposite of theta? Well, opposite of theta is what we just found. That is going to be the square root of 13. So the square root of 13 over my hypotenuse, which is going to be 7. Okay, there's that one. If I do cosine, so cosine of theta, adjacent, that is going to be 6. Okay, and hypotenuse is going to be 7. Okay. And then if I do tangent, so tangent of theta, that's going to be opposite over adjacent. So that's going to be the square root of 13 all over 6. There you go. We're done. We have the three trig ratios. Okay. All right. Let's try another example. Okay. So here's our next example. And you can see that, again, we have another right triangle right here. The only difference here is that theta has changed its position. So the angle in question is now going to be right here. Okay. So technically, my x value right here is now opposite, my 6 is adjacent, and then 10 is going to be my hypotenuse, okay? So before we can get these three trig ratios, we have to solve for x. All right, so why don't we go ahead and get rid of all this here? We're going to do that by using the Pythagorean theorem. So I'm going to say here 6 squared plus x squared equal to 10 squared. So then we get 36 plus x squared equal to 100. So from here I have to do 100 minus 36. That's going to give me 64. So I get x squared equal to 64, and then take the square root on both sides, we get plus or minus 8. And again, we're only going to be using the positive version because we're talking about a length here. So we're only using positive 8, okay? So I'm just going to go ahead and put here x is equal to positive 8, all right? So now we can get our trig ratio. So I'm going to say here sine theta. Well, sine theta is opposite over hypotenuse. So opposite, that's going to be 8. Hypotenuse is 10. And we can go ahead and reduce it. We know that 2 will go into 8 4 times, and 2 will go into 10 5 times. Okay, so there it is, 4 over 5. Now I'm going to do cosine. So cosine theta, that's going to be adjacent over hypotenuse. Now again, the angle in question is right here. So my adjacent side is right here now. So adjacent is going to be 6. I'm going to put 6 over my hypotenuse, which is going to be 10. And again, I can reduce that as well. 2 will go into 6 3 times, and 2 will go into 10 5 times. Okay? And then we're just going to do tangent. So tangent theta, that's going to be opposite over adjacent. So here it's going to be 8 over 6, which we can reduce again. 2 will go into 8 4 times. 2 will go into 6 3 times. Okay? And that's done. All right? Okay, let's go ahead and try a different example. Okay, so this example is a little bit different. They're not actually asking for the trig ratios. They just want you to find x. So how do I do it? Well, I can't use Pythagorean theorem here because I don't have this side here and I don't have this side here. So that's not going to work. So if you run into a situation like this, start thinking about your trig ratios. So if I have an angle of 43 degrees, I can see that right here. What's opposite to that? Well, opposite to that is going to be x. And I know that sine theta is going to be opposite over hypotenuse. So if I write sine and then theta, which is going to be 43 degrees, equal to opposite over hypotenuse, or x over 55. Now all you have is an equation that you can solve for. So to solve it, I'm going to do sine of 43 degrees, and I'm going to have to multiply this by 55. And that is going to give me x. So in your calculator, you want to do sine of 43 degrees times 55. Just make sure you are in degrees when you do this problem. So sine of 43 degrees, okay, and then multiplied by 55, you should get 37.51. So x is equal to 37.51, and I just went ahead and rounded it to the nearest hundredth, okay? We're going to leave it like that. Okay, so there's x. All right, let's try another example. So this one as well, they want you to find x. How do I do it? Well, x is now over here. The angle that I'm provided is 23 degrees, and technically you have 90 degrees here, meaning you could find this angle as well if you wanted to. But just using the angle that they gave us, how could we get x? Well, think about it. Right now I have opposite and I have adjacent, okay? So what ratio is that going to be? Opposite over adjacent. That's going to be tangent, right? So I can say here tangent of 23 degrees is equal to opposite, which is going to be 6, over adjacent, which is going to be x. Okay? So from here, you just have to solve it. Meaning this x and this tangent of 23 degrees are essentially going to be switching places. So for example, you're going to be left with x is equal to 6 over tangent of 23 degrees. Okay? So I'm going to go ahead and plug this into my calculator and see what we get. So again, you're going to do 6 divided by tangent of 23 degrees. When you do that, you should get 14.14 when you round to the nearest hundredth. So I'm going to say here x is equal to 14.14. Okay? And this problem's done. All right. Okay, let's try another example. So here's our next example. Same thing. They want us to find x. So how do I do that? Well, again, the angle that they give us is 25 degrees. And so again, if you really wanted to, you could get this angle here because you have 90 degrees here. But again, we're going to use the angle that they give us and just go from there. So looking at all the information we have here, I have adjacent and I have hypotenuse, meaning I could use cosine here. So I could do cosine of 25 degrees, and this is going to be equal to adjacent over hypotenuse, or in other words, 5 over x. So just like the other problem, we're going to go ahead and make the switch where we have x is equal to 5 over cosine of 25 degrees. And from here, we just have to plug it into our calculator, right? So in your calculator, you're going to do 5 divided by cosine of 25 degrees. And when you do that, you should get 5.52 when you round to the nearest hundredth. So I'm going to say here, x is equal to 5.52. That's good, okay? And that's it. So why don't we go ahead and try one more example. This time it's going to be a word problem. So here's our last problem, and you can see that we're dealing with a word problem. And it says, David stands 75 feet from a pine tree behind his home. The angle of elevation from David to the pine tree is 49 degrees. How tall is the pine tree? So before you do anything, you should go ahead and draw a picture. So that's what I'm going to do. Here's David. So I'm going to put David right here. And we know that the distance from David to the pine tree is going to be 75 feet. So I'm just going to go ahead and put 75 feet as a distance here. This is going to be 75. Okay. And we'll put feet. And then we have the height of the pine tree right here. Okay. So we can go ahead and draw a little tree here. That's good, right? Here's our pine tree. So what else do we know here? Well, we know that the angle of elevation is 49 degrees. So going from David to the top of that pine tree is going to be 49 degrees. So I'm going to put here 49 degrees. Okay. So now I can see that I'm forming a right triangle. I have 90 degrees right here. I can go ahead and use my trig functions to figure out what the height of this pine tree is going to be. So based on the information that I have adjacent and I have opposite. Okay. So that's going to be tangent. So I'm going to say here tangent of 49 degrees is equal to opposite, in this case here, that's going to be h, over 75, adjacent, right? So h is going to be equal to 75 times tangent of 49 degrees. When you do that, you should get your answer. So in your calculator, you're going to do 75, and then you're going to multiply by tangent of 49 degrees. Just make sure, again, you are in degrees. Otherwise, you're going to be getting these problems wrong, okay? So when you plug that into your calculator, you should get 86.28 when you round to the nearest hundredth. So I'm just going to say here, h is equal to 86.28, and that is going to be feet, okay? So that is the height of the pine tree, okay? And we're done. So that's pretty much it. Those are the trig ratios. We dealt with sine, cosine, and tangent in this video. Okay, we did not deal with the reciprocal trig ratios, which would be cosecant, secant, and cotangent. That's going to be for another video. But these are your 3 basic trig ratios that you can use on all right triangles. Just remember, they do only work on right triangles. If you have something other than a right triangle, we have other methods of solving for those missing parts. We could use the law of sines. We can use the law of cosines. We could use Heron's formula. And I have videos on all of that. So go ahead and check the links below. That way you have access to that content. But that's going to do it for this video. I hope that you gained something from it. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future. And I'll see you in the next one.